All right, video 2 here. I'm going to make 3 videos. So this is going to be a short second video on the rectangle property. Okay? So here you go. It says Ashton measures the diagonals for his deck frame and finds that they are congruent. Will the deck be rectangular? So basically this is saying, okay, based off this picture, if these two measurements, so I did label this as A, B, C, and D. So if AC and BD are congruent, will this be rectangular? Right? That's the question. Okay? So if the diagonals are congruent, will this be a rectangle? All right, so here we go. In the deck frame, segment AB is congruent to segment CD. So A, B, and CD. So that's the opposite sides here, 10 and 10. And segment AD is congruent to segment BC. Here and here. So that's like, that was given to us, right? Okay. Because of this, we know that ABCD is a parallelogram. So ABCD is a parallelogram, and that's because both pairs of opposite sides are congruent. So we also were given that the diagonals, segment AC and BD, are congruent. So just like in the previous lesson where we used overlapping triangles, we're going to do the same thing here. The two triangles we're going to use here are ABD and ADC. Again, you could use any pair, just don't use the one that share one of the diagonals, right? The diagonals have to overlap, right? I'm going to draw those two triangles separately. So here's ADB or ABD. And then here is ADC. And again, we know that this is 8, this is 10, this is 10, right? Okay. So let's continue on. So using overlapping triangles, we see that AD is congruent to itself by the reflexive property, because that side is used in both by the reflexive property. We already said that that AB is congruent to CD up here, ABCD, right? So now we have the reflexive property. That's our second pair of sides. So one pair of sides, two pairs of sides, and we were given that the diagonals are congruent. That's your third pair of sides. So these two overlapping triangles are congruent by side, side, side. So triangle ABD is congruent to triangle DCA, ABD, DCA by side, side, side. Okay, now how do we prove that something is rectangular? Well, we need to focus on the right angles, right? In this picture, we need to show that angle A and angle D are right angles, right, between these two triangles, right? So that's our next step. How are we going to do that? Well, we know that they're congruent by CPCTC. So we know that angle DAB and angle ADC are congruent by CPCTC. And we also know that they're supplementary, because this thing is a parallelogram, right? We showed that up here. It is a parallelogram, and A and D are these two angles here and here. They're what we call consecutive angles. And we know that consecutive angles of a parallelogram are supplementary. Well, think about this. If two angles are congruent and they're supplementary, congruent means they're the same, supplementary means they add to 180. What do their measures have to be? Their measures each have to be 90. And therefore, DAB and ADC are right angles. Thus, angle DAB and angle ADC are right angles. And again, it's because they're congruent and supplementary. We can use similar, we could use similar reasoning to show that angle ABC and angle DCB are also right angles. And since the frame is a parallelogram with 4 right angles, it is rectangular. There you go. So that's kind of a long, response there, right? But it's good. And this idea, this might be new to you, but I think we talked about it earlier, is that if two angles are congruent and supplementary, then they're going to be right angles, right? So that's an idea that should make sense to you. So here is the formal introduction of this idea, right? So if we have a parallelogram and their diagonals are congruent, then it is a rectangle. Again, this is a converse from last lesson. So again, if we know that x, z, and wy are congruent, then we know that these angles are right angles. Okay, so I'm going to stop this video here and then make a third video with a bunch of different problems on it involving rhombuses and rectangles. All right, stay tuned for video 3.